All right, so page 325. Here we go. So a family goes driving. This is a graph that represents time of day and amount of gas that they used, amount in fuel in liters, amount of fuel in liters. Okay. Tell me what is happening in these sections. So A to B in this section right here. What's happening? What are they doing? How do you know they're driving? The gas is going down, therefore we're driving. So driving because the fuel is decreasing. All right. What happens between B and C?
They're stopped.
They're stopped. We don't know why. Maybe they're getting food. I don't know. Stop for food. What happens between C and D? They're getting gas because the gas is going up. Fuel is increasing. Okay. Now, trying to fit this all onto the same page. What is the rate of fuel consumption between D and E? All right, in liters per hour. So basically, between D and E, the time here at D is 10:30 and 12:12. That's 2 o'clock. So how many hours did they drive between D and E? If you drive from 10:30 in the morning till 2 in the afternoon, how many hours did you drive? 3.5 hours. So 3.5 hours. How much fuel did they use? What would they start with? Started at 60 and they finished with the 25 I should have hit. Yeah. So they went from 60 liters to 25 liters, which is 35. All right. Tell me what the rate is. What do you do if I want liters per hour? What do you do? All right. What do I do? It's liters per hour. So it's just 35 liters divided by 3.5 hours, which is 10 liters per hour. Where do they refuel for a second time? Where do they refuel for a second time? What sort of section? G to H when it goes back up. How long were they driving? How long were they driving the car? How many hours were they driving in the day? I guess is what I'm asking. You just randomly guessing? How long did they drive for here? From A to B, how long are they driving? 3 hours exactly. So let me clean all this up. So we went from 7 to 10, so there's 3 hours there. And then from C to E, we said that was 3.5 hours. F to G is 1 hour. And then H to I is another hour. So how many hours? Thank you. 8.5 hours. All right. We're not going to worry about the last one. Flip the page, please, once you've got that copy down. Okay. We're going to describe what is happening here. So, who rides a bike? All right. And just in general. Keen, this is you. This is Keen riding a bike. Here we go. We got time on the x-axis. We got his speed on the y-axis. I'm going to call this A section. This is B, C, D, E, and F. Okay. What's going on in A? This is like physics, isn't it? What's going on in section A? What is Keen doing? It's going straight? Steady pace. Because this is speed, right? It's how fast he's going. So this could be like, if I wrote this, it would be like, say, Keen, you're riding really fast, 50 kilometers an hour. Okay? So he's going constantly at 50 kilometers an hour. So steady pace. He's a really fast bike rider. Or motorcycle. What's happening in section B? He's not going down a hill. This is not height, people. It's speed, right? So his speed is decreasing. It's going down. Because if you mark it out, this would be like 25 kilometers an hour. So he's slowing down. What about C? What's happening at C? Steady pace again, because the speed isn't increasing or decreasing. And D? He gets chased by a dog, so he has to speed up. Because of a dog. What happens in E? Steady pace again. And then F. Whoa, that's a bit violent.
What? It stopped moving.
Yeah, but it's a steady stop. Okay, so he slows to a stop, right? Slows to a stop. Okay, now just since you said it,
What?
how would I represent it? Sorry, Keen, this is not my idea. If he stopped suddenly, as in he got into an accident, how would you represent that? It would just be a straight line down. Boom, instant stop, right? It'd probably look like this. If you went over his bars and you measured his personal speed, it would probably be like this, and then he'd hit the ground, basically stop, and then his momentum would increase, and then he'd hit the ground again, and then his momentum would increase, and he'd bounce a bit. He would slow down sort of gradually. It'd be kind of chunky, like boom, 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 boom. Sorry, that was not my idea, Keen. All right. B. We're going to change this from speed to, I don't know, what do you want to put here? I don't even, height? Okay, height.
Easy that one.
All right, there's a height. Time, height. What are we doing? What does this represent?
It's like him bouncing after he falls off.
This is Keen. What do you guys got against Keen? What's okay? Let's say that we go with that, even though that's a bit morbid. Why is this not an accurate representation?
Because he would slowly bounce lower and lower.
Exactly. He's not going to bounce to the same height unless he's like made of rubber or something and was like zero friction. It's a pogo stick. Okay, let's like that. Does everybody know what a pogo stick is?
Lame.
Wow. All right, pogo stick. So you're bouncing up and down on a pogo stick. All right, that's kind of boring. What if you did, we'll draw a graph here. What if you did a ball bouncing? What would that look like? And this was height, and this was time. What would that look like? it would be high, right? You drop it. Say you dropped it off a big building and it went bounce, and then it would bounce up pretty close, and then less, and less, and less, and less, and less.
That doesn't make sense.
That doesn't make sense?
Well, then that wouldn't be an accurate representation, right?
Which one?
For a ball bouncing, because on the graph it doesn't decrease.
Yeah, that's what they drew. I'm just talking about this one here. If it was ball bouncing, yeah, it would just get smaller and smaller and smaller. Okay. 2 more graphs to do, people. Anybody bake pies? Yeah? Abigail? All right, we're baking pies. Here we go. So A graph, we're baking a pie. What type of pie is best? Oh, we already had this discussion, didn't we? Oh, people. Pumpkin. Only if you put like this much whipped cream on it.
Right.
And drown out the taste of the pumpkin. Okay. Apple pie or lemon meringue pie? Who said you to lemon meringue?
Lemon meringue's disgusting. It's lemon.
All right. Oven temperature. So we walk into the kitchen. We turn on the oven. What's it going to do? It's going to heat up. So it goes. All right. Gets to our temperature. Then, so that we'll call this section A. We're going to write out these sections. A is the preheat. All right. We preheat our oven to whatever. What do you bake pie at? 375? I don't know. 325? 350?
450.
Okay. And then it flattens out. So that's us. Like, what is that? What's happening there? I guess it's waiting for us to put the pie in. We're making the pie. How's that?
When you open the oven, it actually drops.
Ah, that's the next bit. So then you get this. C, what happens there? We open the door, right, to put the pie in. And then D. What's happening at D? It's cooking. It's baking.
And something catches fire.
So, whoa. Again, what is with you and the morbid?
It's not. It's just like an accidental oven fire.
What that? We don't want that.
No one gets hurt in the process.
Okay. All right. E. What's happening in E? Okay, so why is E's line, I guess? Why is it
Nice.
not the same angle as A? I guess that's what I'm trying to say. I would say slope, but you guys don't know what slope is, so.
It takes long to cool off that best.
Yes, it takes a long time to cool down because there's residual heat and it insulates itself. So oven cooling. Okay. All right. Here we go. Last one. What do we want this to be? Ben taking part. How about Ollie versus Baldwin in a 100-meter sprint? Yeah, he is, because Baldwin's fast. Like 45 years ago, I was fast. All right, here we go. Who we want to draw first? Baldwin or Ollie? No, we're not going to do a race. Found what? All right, I'm going to be in red. Yeah, it is. You're going to lose anyway.
I think we should test this oven.
Okay, here is Baldwin takes off. And he shoots up to maximum speed. In 3 seconds, I hit my max speed. No, hey, again, morbid. You are so mean. I'm gonna draw yours in here in a sec. All right, and then starts to slow down. Do. What's my? How long does it take me to do 100?
Too long.
5 hours? Minutes? Who's measuring this in minutes? Whoa. 9.6 seconds. Why did I put it there and not here? Because when you cross the finish line, you're not at 0, right? Correct?
You should be at 100 when you cross the finish line. Why are you going so slow? It's only 100 meters.
9.6 seconds is slow.
No, but you went so fast and then all of a sudden you're going slow.
So that's a good question, because that's, I guess, it was overly dramatic, but when you run 100 meters, you reach maximum speed. You actually reach it at 60 meters. And then after 60 meters, everybody's slowing down. What?
Just like slow down at the start and then sprint at the end.
Not
Not
100 meters. Not
fast
first and then.
It's 100 meters. Do you know how far 100 meters is? It's like a soccer field. It's very short. Like in the Olympics, like a 100-meter dash. Usain Bolt. Anybody ever heard of these names? I know. See, I'm like right there with them. In a 100-meter dash, you reach max speed at 60 meters, and then everybody slows down. The person that wins is the person that slows down the slowest, if that makes any sense, or the least amount. All right? That's what it is. Because you can't keep running and increasing your speed forever. Anyway, Ollie. Here's Ollie. Gun goes off. Boom. Ollie just sits at the starting line for a bit. And then starts running. Gets tired. Slows down, and then he starts running again. I'm getting a little faster. Slows down. And then he just stops. He's like 30 meters in, and he just stops.
Yeah, what?
Yeah, that's not very good.
People, this is not a measurement of distance. What are the units here? Time. This is not how far he's gone. All right? It's time versus speed. It's not distance. Okay? All right. You want to put it to a test? Maybe. What?
I want to see the 9.6 seconds.
I only bust that out on certain days.
You said 45 years ago. So you were
Yeah.
like, what, 30?
Oh my gosh. You are so mean today. Fine, I'm done. 2, 3, 5, 7 to 12. I'm going to cry for the rest of the class now. You are mean people. Sorry?
Found your lookalike.
Oh my gosh. You guys are so mean. The meanest class ever.